Hi everyone, let's solve today's daily challenge. I actually uploaded the video in the morning, but it had no voice. So I'm gonna re-upload it. So let's see. So in this problem, we are given the head of a linked list and we need to return the node where the cycle begins. So if there is no cycle, we need to return null, right? So this is the definition of the cycle that is given to us, and for that also you are also given this pause variable to know, where the cycle is. For example, in this first test case, so basically, see, a cycle appears when you revisit a node that has already been visited, right? So here, if you see, you start from the head, right? This is the head, 3 is the head of this linked list, and you start from 3, then you go to 2, then to 0, then to -4, and then from -4 you go again to 2. So 2 you have already visited. So you say that, okay, so here we have a cycle, right? So cycle, basically cycle forms a loop kind of a structure, right? So when there is a loop, there is no end. So when there is a cycle in a linked list, you will never reach null. That is the end of the linked list because of this particular pointer here from -4 to 2. So this is creating a cycle. So you will keep on traversing this list, right? So if you see this question, so there is a very standard way to solve it called Floyd's algorithm. But before we discuss it, right, what comes to our minds first, right? So what we will do is, what we are saying is that we are just checking whether the node that we are currently at, if it has already been visited. So what can we do? We can take a hash map, right, and we can while traversing the node, we will be putting all these nodes inside of the hash map, and simultaneously we will be checking whether the node that we are at currently at, if that has been already visited, right? So if it has been visited, then what will happen? You can easily say, right, this was already inside of the map, and we have, so that means we have visited, thus there is a cycle at this point, right? The very first point you get, which already exists in the map, that will be your head of the cycle, right? So here you see cycle begins here, right, from 2 to 0 to -4, and then from -4 to 2 to 0 to -4, this way, right? So here you can easily see there is a loop that is created. So you can use this method that we just discussed, right, taking a map and putting the values of the nodes inside of that map, and wherever you will witness a node which has already been visited, you can say, okay, so this is the point where we are, so after this point we have again reached the point that we have already visited. That means there is a cycle from starting from this point. Now if you see, we'll be utilizing extra space, that is O of n, right? So why? Because we will be putting we'll be taking a map, putting these nodes inside of the map. So in the worst case, what will happen? We will be putting all the nodes inside of the linked list inside of the map. So we will be using extra space of big O of n, right? So Floyd said we don't even need that, right? So he said, okay, wait. So Floyd was like, we don't even need to utilize that extra space, right? So he gave the concept of two pointers, right? He said we will take one pointer as slow and other pointer we will take as fast. Now, why are we taking these pointers? So what he said is this slow pointer, while traversing in the linked list, this slow pointer will be incremented by 1, right? So it will be moving one step ahead in each in each iteration, and this fast pointer will move 2 steps ahead, right? Right, so because it's moving 2 steps ahead, that means it is obviously going fastly, so it is called fast, and it is called slow, right, because it is moving only 1 step ahead. Now let me draw the linked list and understand how this will help us to detect a cycle in the linked list, right? So okay, so this is a linked list and here we have a cycle, right? So what Floyd said, we'll take a slow and a fast point. So initially slow and fast will be at this position, right? Slow and fast will be at this position. Then what will happen? So in the first iteration, what will happen? Let me take a different pen for this. Okay, so for the slow pointer will come at this position, right, in the first iteration. And where will the fast pointer be moving at? The fast pointer will come at this position. This is in the first iteration. In the second iteration, what will happen? In the second iteration, the slow pointer will be at this position and the fast pointer will be at this position, right? Then in the next iteration, what will happen? Sorry, the past pointer will not be at this position. Past pointer moves 2 steps ahead, right? So it came from here to here. Now fast pointer will skip this and move to this position, right? Our fast pointer is at this position. Then let's move our slow pointer here. Then what will happen? Our fast pointer will come at this position. Now you see that our slow and fast pointer have become equal, right? So let me consider, so before I tell you the conclusion, let me discuss it for the case when we don't have a cycle here, right? So let's consider this linked list. Let's say we have this, right? And here we have null. So here what will happen? Again, you take slow and fast pointers and you initialize them to the head of the linked list. Then you will take the slow pointer here, the fast pointer will come here, right? Then in the next iteration, what will happen? Our slow pointer will come here and the fast pointer will be pointing to null, right? So basically what will happen is, when there is no cycle in the linked list, right, as fast is obviously going faster than the slow pointer, fast will be reaching the null, right? Fast will reach the end of the linked list, that is null, right? Similarly, like, okay, so you will say that fast will not reach the null if these number of nodes will are odd, right? In that case, we will check fast and next of fast, right? So when the nodes will be null, fast will be just before the null. So if so, f of next will definitely be null in that case. So we can simply use fast and fast of null next to see whether we have reached the end of the linked list or not. But when there will be a loop, we will be going forever, right? We will never reach a null. So that is very clear. We will never reach a null. So if we will not reach a null, we will be arriving at this condition. Okay, wait, I rubbed everything. So we'll be arriving at this condition, right, where slow pointer and the fast pointer becomes equal, right? So this is the concept. This is how Freud said that we can do, detect a linked list, a cycle in a linked list within O of one space, right? That is constant space. So this is the procedure to detect a cycle in a linked list, right? So let's write the logic for this first, right? So let's first it's because when we will be having a cycle, then we have to return its head, right? Otherwise we have to return nulls. First let's check whether or not we have a cycle here or not, right? So let's first make our pointers slow and fast. Node star fast is equal to head of the linked list. Now these 2 pointers will be initialized to head of the linked list, right? Now we will be traversing, right? So I said that we will be traversing until either we reach the end of the linked list or this condition becomes true, that is s is equal to f, right? So let's do that here. So we'll be first checking that if fast and fast of next, if they are not null, right, only then we will be going inside of this loop, because when they become null, what will happen is we will reach the end of the linked list, right? And why are we using fast? Because obviously fast is going faster than the slow pointer, right? So if the linked list is very big, then we can reach the end of the linked list faster using the fast pointer, right? Now what we'll do, we will move the slow pointer by 1 step and we will move the fast pointer by 2 steps, that is next of next, right? Now let's take a bool value, right? Let's take a flag variable. Inside of this, what we will check, like initially it will be false, right? So if it is false, then there will be no cycle in the linked list. But we saw when this condition becomes true, that is if slow is equal fast, right? So this condition will never be true if there is no cycle in the linked list, right? So if this is true, that means there is a cycle. So what we will do, we will say flag is equal to true and we will break from the loop out here, right? So this is what we will do. So this flag variable now will be storing whether or not a cycle is present or not, right? So if the cycle is not present, in that case we have to simply return null. So we'll say if not flag, simply return null, right? Otherwise we need to return the head of the cycle, right? So let's see if there is a cycle, how we will be, calculating the head. So to calculate the head, Freud said, so let's take a general diagram, right? This is the head, right? And from head, this will be the head of the cycle, right? So let's say this is the loop, right? This is the linked list, right? Where sorry, this is the part where we have a loop, right? So this is a very general case. Now what will happen is, this is the head of the linked list, this is the head of the cycle, and let's say this is a point where our slow pointer and fast pointer have become equal. Now what happens is, if you calculate the distance from head of the linked list to the head of the cycle, and if you take the distance from where the slow and the fast pointer have intersected to the distance from the head of the cycle, right? These two distances, Freud said, are equal, right? These two distances are equal. So what we can do is, we can take a pointer at this particular head, and we already have our slow and fast pointer pointing to this intersection point, right? So what we can do is, if we take one step from this point, and if we start taking one step from this point, right? So wherever these two pointers meet, right, that will be the head of the cycle, right? So that is what we are going to do. Now see, we have two pointers here. So what we can do is, we can simply use one of them and point them to head of the cycle, right? So let's do that for fast. So we will be taking fast variable, and we will be initializing it to head of the linked list again, and then we will be incrementing it by 1, and similarly we will be incrementing our slow pointer by 1 here also, right? So wherever they meet, right, that will be our head of the linked list, because these two distances, right, these two distances, that is from head of the linked list to the head of the cycle, and from head of the cycle to the intersection point of slow and fast pointer, they are equal, right? So we'll be using this concept. So let's code it out as well. So what we will do, we will first take our fast and initialize it with head again, and we will be incrementing fast and slow both by 1, right? So let's do that. We will say until they both are not equal. So until fast is not equal to slow, we will increment them by 1, right? So fast is equal to fast of next, and then slow is equal to slow of next, right? So when they will become equal, we will be coming out of this loop, and we can return easily one of these values, right? That is fast or slow. So this will be our head of the cycle. So that is what we have to return. So let's quickly run it and see if this works or not. Okay, it's giving us TLE. Why is it giving us TLE? This is fast up next, this is slow up next. Flag is equal to false. That is what I did at that time also. Okay. Okay, wait. This is also correct. Let me open my summations in the new tab. Slow of next, we have slow of next. Okay, so let's see. So we took two labels here. took two variables, took poles, we took first and fast took next. One distance and this by 2. Here we check this. We are doing everything the same. Why is it not getting accepted? Oh, okay. I wrote it as slow. Okay, so this will be fast. Okay, sorry for that. Okay, so it's accepted. So this is how we have to solve this question. Very sorry for the silly mistake. Okay, so basically we'll be taking two pointers, slow and fast. So slow will move one step ahead and fast will be moving two steps ahead in each iteration. And if fast or fast of next, if if any of these two values become null, what will happen? We will, we can easily say that we have reached the end of the linked list. That means there was no cycle, right? But if we don't reach the end of the linked list, these will, never be null, right? So will we keep on going forever, but there will be this condition, right? At one point slow and fast will become equal, right? So when they become equal, we can say that there is a cycle in the linked list, right? So that is where we set our flag to be true and we break out of the loop. And then what we have to do, this is the second part of the code, right, where we have to return the head of the linked list. So what we did, we checked if fast is not equal to slow. So we saw that with this diagram, right, that this distance from head of the linked list to head of the cycle and from the intersection point to the head of the cycle is equal, right? So that is what we have used here, right? So here we have done the same thing. We initialized fast with head, and from head we are traversing towards the head of the the cycle, right? Here we are coming. So obviously if these two distances are equal, so if we increment this pointer by 1 and this pointer by 1, we will be intersecting at this point. So whenever they become equal, we say that whatever pointer we are at where they have become equal is the head of the cycle. So that is what we will return. So this is how we have to solve this question.